Hello everyone, I am Samit Jainand. Today I am excited to present our project on smart irrigation system. Here is our project contains introduction, project aims, project background, project objective, methodology, system architecture, project timeline and budget, result and key finding, and discuss. Let's move our first slide, project introduction. In this presentation, we will introduce a smart irrigation system designed to optimize water usage and improve plant health. The system uses Internet of Things technology to remotely monitor or control the field based on real-time sensor data. Project aims and significance. Our project aims to achieve several key objectives. Optimize water usage with real-time data, improve crop quality and yield, reduce labor and cost, promote environmental sustainability. The significance of our project lies in its potential impact, efficient water conservation, enhanced crop resilience, economic viability, environmental stewardship. Let's move next slide. Project background. In this slide, we will discuss background of the project. Conventional irrigation systems are more often problematic. Overwatering can cause root rot and leaching of nutrients, while underwatering can instant growth and reduce yield. Also, if there is not enough water supply, the plant will dry up and the growth will be stunted and the yield will be reduced. In addition, inefficient irrigation practices can contribute to soil erosion. These traditional techniques create many inefficiencies. Hence, there is a remarkable trend toward adoption of smart irrigation system. These systems use many sensors and smart devices. This reflects a broader trend toward precision agriculture. Let's move next slide. Project objectives. In this slide, we will discuss main objective of our smart irrigation system. The Node MCU microcontroller acts as an main controller, processing sensor data and controlling the water pump. The sensor provides real-time information on soil moisture, temperature, and humidity. The main display provides local visualization and the blink app enable remote interaction, remote monitoring, and control. Methodology. Here are 4 slides for the methodology of an IoT-based smart irrigation system. First one is system design. This slide outlines the design process for our IoT-based smart irrigation system. We will focus on selecting the appropriate hardware components, design the data communication architecture, and developing the software for data processing and activation control. Second one is software tools. In this slide, we discuss the required software tools Arduino IDE and Blink app. Arduino IDE is a free and open source platform for writing and uploading code to Node MCU microcontroller. We use it to read sensor data, control the water pump, and communicate with Blink app. The Blink app on smartphone or tablet provides a user-friendly interface for remote monitoring and control of the irrigation system. Third one is testing and deployment. This slide highlights the testing and deployment procedures for our IoT-based smart irrigation system. Rigorous testing ensures the system functions as intended in harsh environments outside of real-world conditions. Proper deployment includes proper installation of the system, proper control of system performance, and training of users on maintenance. Fourth one is evaluation. This slide describes the evaluation process for our IoT-based smart irrigation system. In this, we monitor system performance, collect data on water usage, plant health, and analyze overall effectiveness achieving project goals. Evaluation is very important to measure the success of the system. Performance monitoring helps in the identify any kind of technical problems that may arise. System architecture. In this slide, we discuss project architecture. System architecture follows a layered approach. The perception layer consists of the sensor that measures soil moisture level and sensor responsible for collecting environmental data. The network layer uses Wi-Fi to communicate with internet through Node MCU. The processing layer consists of Node MCU which analyze the sensor reading and control the water pump through the relay module. Finally, the application layer includes the Blink application for remote monitoring and control and the display for local data visualization. Project timeline and budget. Here is a slide for project timeline and budget for IoT-based smart irrigation system. In this slide, we discuss the project timeline and budget for developing an IoT-based smart irrigation system. A well-organized timeline will ensure that the project is properly managed and deadlines are met. A fixed budget will help us use resources effectively. Let's move next slide. Result and key finding. In this slide, we discuss the project result and key finding of this project. The data from sensor installed in the field can be accessed remotely through the Blink app, allowing users to remote monitor soil moisture level, temperature, and humidity. Based on this data, thus making decisions based on field requirements enable remote control of water pump through mobile phone without visiting to the field. As a result, this system helps to provide only the optimum amount of water based on the plant's need to promote healthy plant growth. Let's move next slide. Project discuss. Finally, we discuss as the benefit we get from this smart system. Water conservation, improving field, low labor cost, remote monitoring and control can be indicated. In the beginning, should need to spend high cost can be introduced. This system is mainly dependent on internet connectivity. As future improvements, we can introduce integration with advanced sensor. As an example, nutrient sensor, insect hazards detection sensor, soil nutrient sensor, and drone technology can be extended. Let's move our final slide. Thank you. Thank you all for your attention. I am happy to answer any question you may have.